this is lesson 15, and I guess I'll have to write the word out. Equilateral. There's really not an abbreviation. Triangles. Oh, I guess I could have done it that way. But anyway, I'll just do triangles twice. Isosceles triangles. Okay, so we want the blue one first, the little one first. And I hope I know where I laid mine. I think I put it in here. I think I can do the colored ones under my camera now. That old camera didn't like them, but I think my iPad will let me do it. Let's write on it before we glue it in. Did I have glue stick on it? I didn't. Okay, well, just hold them, and you can get your glue sticks when we get through, because the notes shouldn't take too awful long today. Okay, a triangle is equilateral if and only if, we've already had this conversation, if it is equiangular. And I guess that was an exclamation point. I'm not sure what that was. It says, there they are. I wondered who those were, Ella. And we've already said that if it is equilateral, it is equiangular. So, and look at what they're saying. If the measure of angle A and the measure of angle B and the measure of angle C are all the same, then we know that that makes it equiangular, right? And by the way, if and only if means it goes both ways. I don't know that I can give a good example. I'm going to Walmart if I'm going to Kroger's. I don't know that I can't really give a good example. It just means a triangle's equilateral if it is equiangular, and it's equiangular if it's equilateral. What's the best way to say it? It's both of them. If it's one of them, it's both of them, either direction. So if all three angles are congruent, you remember the notation for that? You put little arcs in them, like if you put one arc in each corner. Then if the measure of the angles are the same, then the measures of the sides are the same. So then we can say, you remember how we might measure segments? We haven't done that in a while. It's we write the letters without anything above them. So that's the measure of segment AB equals the measure of segment BC equals the measure of segment AC. And then go the other way. If the sides are all equal in measure, then all the angles are equal. So the measure of angle A equals measure of angle B equals measure of angle C. And I'll just tack that in real quick. And I'm sorry I didn't tell you. I remind you. I get in my brain things, and then last night I started typing the, if you've got one in your bag, but don't get up and get it if you don't have one. You can glue them in when we get through. Just kind of leave you some room up there. Now let's do an algebra problem. This one's gone anyway. Let's do an algebra problem with an equilateral triangle. So problem number 1, geometry. Where's the equilateral triangle? I think it's up there at the top. Don't they just call it the triangle? As we get further into geometry, I would encourage you on some of these lessons to print the lesson. If it's 2 sheets, which I think the one today is, you would want to print it. I don't think it's 3, but it's a different worksheet. You'll see when you look at it, it's not my typical generator. You can tell what mine look like when I generate out geometry problems. But it's got some pictures that you could either draw and write on, but sometimes I'll tell people you may want to print it. And the only thing is, I do ask you, if you do print it in here or any teacher's room, be sure and print it 2-sided. It just keeps from wasting paper. Okay, in this case, you're given that it is, I guess it would say, well, here's what they would do. They would do this, and they would do this. So that automatically tells you it's equilateral and equiangular. And they write on this one, 9y plus 1 is this side. And this side down here is 10y minus 20, oh, can't read. I think it's 11y minus 23. That light reflects right off of that. That's this side. And then this side over here is 14y. I'm going to turn it sideways. I think I can do better than that. 14y minus 59. And then down here in the corner, they put that this angle, and I don't know how to do that other than maybe a little arrow, and they put that that is 7x minus 3. Now, we haven't had problems, I don't think, unless we've had a worksheet like this one, that had an x and a y in it. So the question is, what is x blank and what is y blank? Let's do y first, because that's probably the easiest. Well, you have a couple of choices, too, when you do y. I'm going to do the work for y right underneath here. If all the sides are equal, if all their measures are equal, the triangle's equilateral, then how could we find y? Do you see all the sides have a y in them? Then how could we solve for y? If all the sides are equal, what could I say? Say it one more time.
Just figure out one of the sides.
And how would I do that? What do I know about all the measures of the sides? Think about it. They're all equal. Now, I don't want an equation with two equals in it. That's not really an equation. That's just a statement. Could I choose any two? That's kind of interesting, because I could choose these two. There's 3 ways to do it. You could choose these two, or these two. Does it matter? It doesn't. Which two look the easiest? That's what I would do. I probably would do these two. Do they look the easiest? So I'm going to say 9y plus 1 equals, and that's kind of weird, because you're thinking, those look totally different. You know, how in the world could they be all equal? But it's an equilateral triangle. They are. I'm going to move the 9y, because most of you like to get away from the negative. So I have 1 equals 2y minus 23. Add 23. And I'll show you how I know it too, and we'll get it here in just a second. And we get y is equal to 12. Now, I'm going to pull my calculator and show you that it's got to work. Because, I think you can see that one. If I put 12 into each one of these, if I say 14 times 12 minus 59, I get 109 units for that side. Okay, let's put 12 in that one. 9 times 12 plus 1. Not a surprise. I get 109 for that one. And then 7 times 12 minus 3. Oh, what did I do wrong? Oh, that's the angle. That's x. I thought, what did I do wrong? 11, there we go, times 12 minus 23. And there's my 109. So y is 12. No matter which one you put it into, there you get 109, there you get 109, and there you get 109. So we got our y. Now, they look like they don't give you enough information in this one. How are you going to solve for x? Well, let's talk about it. How many degrees in a triangle? 180 degrees. Let's go back up here on this one and write on it. If they're all the same, I don't know if we said this and wrote this the other day or not. I did in one of the classes. I don't know if I did it blue or gold. Then what is true about each of these angles?
60 degrees.
They're all 60 degrees. So they didn't have to on this one. They could have. They could have done it like we did this one and put 7x minus 3 and put something else up here and something else up here. And I would have set 2 of them equal. But in this case, I know 7x minus 3 has to equal what? 60 degrees. Put the degree there if you want to, just to understand where it came from. I'll draw an arrow, because that one you got to think about. Now, if they'd given it as 2 separate angles, you would have set them equal. These are definitely, that's one reason I like this. This is some materials that I bought off of Teachers Pay Teachers, and I like them because they're a little bit more advanced algebra, geometry, and it's good ACT problems, because that's the kind of stuff they would make you think about, not just straight do the arithmetic, you got it. Add 3 to both sides. I forgot to almost do that. And I got 63. Divide by 7, I get x equals 9. So you're going to have some problems where you're going to have to think about them a little bit more. Okay, we're gonna glue this one down here, but let's write on it first, and then we'll do 2 problems on page 37. Okay, let me get it to where I get it on screen. Okay, actually, I'm gonna take it off. I think you can see it better if I do it this way. Okay, parts of an isosceles triangle. Now, we got some new names here. The 2 congruent sides are called legs. They're marked like this. So in this case, segment AB is a leg, and segment BC is a leg. Now, it doesn't have to be standing on those. You know, it looks like they're legs because it looks like it's standing on it. But here is, I think you might have had this one in classwork the other night, where you had the, I think it was like this. It was the right isosceles. By its angles, it's a right, and by its sides, it's isosceles. Well, that's a leg, and that's a leg. So you want to look for the 2 sides that are the same. So they may be turned this way. I know originally why they called them legs is because it was, you know, standing on it if you show it like that. And then this one over here is called the base. So it doesn't necessarily have to be the bottom one. So we'll write that, but I want to make you aware of that. I think one we're going to draw will probably be turned a little bit different. Well, no, I've actually got it sitting just like that one. And so then it says the angle where the legs intersect is called the vertex angle. So angle B is called the vertex angle. It's the angle between the 2 congruent sides, see, where the legs intersect. The opposite side, the vertex angle, across from that is the base. So this is a leg, this is a leg, and this is the base. Now, here's one is called, let me just underline all those. The angles along the base are called base angles. So angle A and angle C are called base angles. Now, this sounds really complicated, and I'll tell you to you kind of like I said, we used to teach it in the way I think I learned it in high school many years ago. It says, and this is one of those if and only if, and they kind of write it, they say the isosceles triangle theorem, and then they do the converse of it, which means they're going to just go backwards. If 2 sides of a triangle are congruent, if a triangle is isosceles, that's an easy way to say it, then the angles opposite those sides are congruent. Another way to say that is you can say the base angles of an isosceles triangle are congruent. So there's the leg, and there's the angle across from it, there's the leg, and there's the angle across from it. So in this case, and I think we wrote that angle A, and they call them angle 2 and 3, we said angle A is congruent, using this picture, is congruent to angle C, and a shorter way to say that is base angles are congruent. Now, this is just the opposite of that. If the angles are the same, then the sides across from them. So the arrows go the other way. If you have 2 angles the same, then the sides across from them are the same. So in this case, we can say that segment AB is congruent to segment BC. And let's see if I wrote anything else on that. I did not. I'm not sure what else you could say. The angles across from the congruent base angles are congruent. The sides across from them are congruent.